All right, thanks everybody for joining today's webinar. The topic for today is beyond the spreadsheet, cloud-based data access, aggregation, and real-time analysis to broaden understanding and inform decisions and engage with stakeholders. We're really excited to give this webinar today at Wellntel, and we have a number of our team available to speak to different components of this. My name is Joe Fillingham. I'm the Science and Information Manager at Wellntel. I'll jump back in just a couple minutes to provide some kind of real-time visual tour of our analytics dashboard platform and provide some specific examples for monitoring networks around the country. But to start things off and to kind of provide a nice background for who we are and what we do, and then also to provide some context around the subject of this particular webinar, I'm going to hand it first to Nick Hayes, one of the co-founders of Wellntel, and then to Marion Singer, the other co-founder. And so why don't we get started with that? Nick, you want to jump in?
Sure, Joe, thanks. Can you move to the next slide? I'm going to do two quick conversations. The first is, for those that are not aware of what Wellntel is, let me provide a quick overview. We are essentially a water information provider or water information system company. We began first in 2013 by working on creating a series of accurate, cost-effective, and very informative sensors that could be used to collect groundwater level information from a wide range of existing infrastructure and resources, like domestic wells and small ag wells and small municipal wells, as well as existing monitoring stations. And that's what you see on the left. But as soon as we began to deploy these sensors around the country, we learned that really the value of these networks is in the networks themselves. That is, the data that come from many sensors in an array presented alongside each other geographically or in time to produce reports and understanding in real time so that folks who manage water can make decisions. And so today we work very closely with farmers and ag businesses and water utilities and community leaders and citizens to gather these data and assemble them into networks so that they can take local action to make sure that the water is being used in a sustainable way. Would you mind moving slides, Joe? We do this with a broader technology platform than just sensors. You can see many examples of sensors being deployed in the field on the left. But as you assemble one class of water data into a database, you realize that it's important to bring many other data types into that same system. And so over the years, we have begun to bring real-time information on many of many types to the same system. So we monitor pumping and flow in gallons when water is being extracted from a groundwater source or a surface water source. We assemble groundwater data from other agencies. That can be level data. It can be quality data. It can be data that's being collected by governments and that might be incorporated into the same data set. We now measure surface water, and that allows us to tie groundwater and precipitation and what's happening in a river or a pond or a stream or a spring together. And finally, we measure the weather too. And we bring all of this into a data management system and present it through what we call our analytics dashboard, which is sometimes assembled in a way that allows people to manage their own operations, and sometimes is assembled in a very scientific way, that is providing things like contour maps and et cetera to drive decisions and reports. And the focus of today's conversation will be a general tour of the analytics dashboard, because it's how information is actually made useful. So with that, let me hand it off to Marion, who can take it from here.
Great, thanks, Nick. So as Nick said, the focus of today is going to be on a tour of the analytics dashboard. But what we're going to highlight is how the analytics dashboard takes you really beyond the spreadsheet. And thinking on it, the default tool in water management has been spreadsheets. Spreadsheets are infinitely better than where we started, which is pen and paper. But getting to analysis with them is cumbersome and time consuming. And most of the time, that work is not the value add. The value add doesn't happen until water managers and their consultants can really engage around the data, gain insight, and make decisions. So what we're going to spend today doing is sharing with you how Wellntel is transforming and streamlining data assembly and analysis so that teams can engage around the insight that they are seeing, and then get to decision making in a much more effective way. We'll share a couple of examples from some folks that we're working with in a couple of different places in the US, and we'll go ahead and let Joe get started.
Great, thanks, Marion. This is Joe Fillingham again. I'm going to exit out of this presentation, minimize it, and jump straight over to the analytics dashboard. I have two different browsers open with two different examples, and I'm going to jump over to the other after this first one is done. So this is the analytics dashboard platform that Nick and Marion spoke about. This is the view that a water manager or network sponsor or anybody that's engaging with the data that's being brought forward from a monitoring network would land on after logging in with their credentials. This particular network that we're looking at happens to be in southeast Wisconsin. I'll zoom out on the map here so we can get some context around where we're looking. There's the state of Wisconsin. It's in a community called Richfield that happens to be just northwest of Milwaukee, which happens to be where the Wellntel headquarters are. So it's a network that's close by to us, and it's one that we support with some field work and things like that as well. This network was started by a hydrogeology professor who lives in this community and was really concerned about the growth of the community, the use of water in the community, and the availability of that water, and tracking that availability and the impact of use and different trends over time. So this network really started back in 2003 with the first kind of manual tape down measurements of water levels in the domestic use wells and homeowners in this community. And from there, it grew into a platform or a network that included real-time measurements. And a lot of those real-time measurements are now done with Wellntel sensors. You saw a picture of those a little bit earlier. And the dots that you're seeing on the map now are actually those same Wellntel sensors. So the reason that we're landing on this particular network is because it's a great example of bringing together or highlighting this process of data assembly from a network that's been around for quite some time and has a number of different types of measurements and things like that, and how Analytics Dashboard can support that data assembly and allow you to then visualize and see these data. When you log in, you land on this page, and the focus straight away is on the network, and you get some kind of fundamental operational information about the wells that are in that network. You can click from one to the other and view trends in those wells with years compared to each other, and you can view some operational information about the well itself. You know, the most recent battery voltage, when it last communicated with the Wellntel cloud system, and a lot of this data is coming into the cloud in real time. I'm going to jump over to hydrographs, which is the tool and the feature that allows users and scientists and water managers and folks involved with this network to view the data that's being collected here in its entirety. So everything from specific water elevation or depth to water measurements to everything else. And I'm going to just pick on one particular well that is in this network and just highlight how quickly and easy it is to bring up a visual and a chart of groundwater level information. From here, you can select the date range within which you'd like to view these data. You can zero in on a particular date range and have the chart do that. I can go from looking at a whole year's worth of data to looking at simply 1 month's worth of data or 2 months worth of data, if that's the right way to do that. Zooming back out, I'm gonna pick on a couple years worth of information here. So if I zoom out even further, we can see some broader context and information. And from here, we can start to do some really quick and easy mathematics and statistics with these data. We can look at things like the daily average water level. We can look at the daily minimum depth to water, which might be important for specific pieces, whether it's elevation that would represent maximum or however you'd like to view it. And from here, we can even start to bring in other data sets. So it may be that we want to compare 2 wells to each other, or even 3 wells to each other. And what's interesting about this exercise is that a lot of these wells are at very different elevations, and the change in water level that you see at some of these wells is such that it doesn't allow you to really view that change given the scale of the depth to water range. So we've built in tools that allow that to be much easier, like normalizing to the period well average, so that you can see all the wells together in a format that shows you the change in water level relative to each well's average for the period shown. Another thing you can do is work with colors in a way that's meaningful or useful, and you can work with different ways of viewing these data by bringing points into the chart, by looking at different formats that can highlight or bring together different components. Another key component of this network that is really interesting is the care that was taken to distribute these wells in a way that is super meaningful. And so one thing we like to highlight with this network is the ability to look at it from a contouring perspective or a mapping or spatial analysis perspective. So the distribution of the well locations, which in this view you see as the black dots, allow for a really clear and clean spatial analysis view. And in our mapping tool, you can start to do this work with great effect, whether that's looking at a contour of water elevation or depth to water, or the change in water level over time. You can use these tools in a way that can be really effective. We've even built in different models that allow for the interpolation that's done on a regular grid to be changed and help inform that sort of analysis. One other key visual tool that we are really excited about is the opportunity to bring in a bubble map, where you can look at the change in water level in a slightly different way. So instead of connecting points across the network, you can look at the network as a whole and the change at individual locations through time, and use a scroll bar to look at that change and analyze that change as you go. One of the key components of spatial analysis is the opportunity to not just view some of these, really interesting looking contour maps or bubble maps and things like that, but to zero in and focus on regions or components of a network that are really critical, like groups that you may want to create. So bundling together areas or specific wells so that you can create a contour map of groups that fit that model. And so we've incorporated a tool that allows you to designate and group wells together for a network in a meaningful way. I'm not going to spend a ton of time on this. It's pretty straightforward, but you can assign as many groups to a well as you want, or as many wells to a group as you want. And you can create as many groups as are meaningful for your network. And once you do that, you're able to then refilter by group. And that allows you to really zero in on specific regions that may be of particular interest for an analysis or for the user themselves. I'm going to jump back over to hydrographs, and I want to talk a bit about that data assembly component again. And what I'd like to do is pick on the wells that I've already selected here. I'm going to zoom out for quite a ways, actually. So instead of just looking at the last couple years worth of data, I'm going to go all the way back to, let's say, 2012. And pick the 1st of January for that. And you can see for each of these wells that they came online some time after that, which is why they start here in 2017. But if I scroll down, a lot of those manual measurements that were collected and saved and analyzed for this network prior to the real-time sensors being installed were uploaded into our system and allow for them to be brought into this sort of analysis. So if I pick on the wells that are already shown, for example, we can start to overlay from 2012 forward the tape down measurements that were also collected with these and start to analyze how both they work together and how the real-time data is providing context and important detail now that wasn't collected before, but also compare the trends for some of these data that were collected prior to what's been going on in the past several years. So a really interesting example of bringing these data together, assembling them in a really easy way from multiple sources, and then analyzing and visualizing them that hopefully will lead to informed decisions about patterns and trends and resource management in general. With that, I'm going to pause and I'm going to switch over to another network that I have open in a different browser. You can see I've landed directly on hydrographs, but I'm going to click on the Wells tab to provide some context to this network. This network is in Central Texas. It's a smaller network than the one we just viewed, but it's one that's actually growing as we speak. New systems are being installed this summer. And you can see that it's in between San Antonio and Austin, which is a really busy area within Texas, and it's one that is very concerned about water availability and water use. This is a community-based network. This is run by a conservation district in Texas, and it's one that has partnered with well owners and homeowners in this region to monitor groundwater levels at their locations, similar to that network in Texas. I'm actually going to pick on, just for the sake of visual and example, the two wells, number 1 and number 4 in this network. And they happen to actually be neighbors. So they're right across the street from each other, or I shouldn't even say across the street. I think they're on the same block and just neighboring homes. And the wells themselves are only a few hundred feet apart. This, from the network perspective, provides a really interesting opportunity for them to analyze different properties of the aquifer. And so one thing that we've done with this network and their science team is track these two wells together over time. So what we're looking at here is the earliest data available for these wells, which was back in 2018, late 2018 through November 2019. There's a couple of periods that I want to bring forward and highlight, but you can tell already how interesting these two wells are and that they track together really clearly. Each of these periods that you're seeing as a dip is interesting in and of itself. They represent pumping events, so drawdown and recovery as the pumps in these domestic use wells turn on and off. So if I zoom into a particular region of data, you'll actually see that you have this pump start, pump stop, and then recovery pattern for each of these events. And that is being tagged by the sensor in the field and allows us to then view, and also allows us to filter out, if we so choose, those individual pumping events from these wells, and just look at the water level data from as close to static as is going to be possible for these domestic use wells. I'm going to turn these pumping events back on again and highlight a particular time range that's really interesting. So again, getting at the assembly of these data, but then also the analysis and visualization of these data using this tool. There's a period of time that we put a bunch of effort and attention around when we heard from the well owners that they were going to fill their swimming pool. So with the scientists in this network, what we did was actually track when that filling of the swimming pool started. And you can see that here in the blue line for well number 4, when the pump is cycling to fill a pressure tank and being drawn down, filling the pressure tank, and then recovering, and then the pressure tank is drained, and so on. It continues. But what we did is we increased the frequency of measurements at both of these wells. And so to view that, I'm going to switch over to a lines and points view just briefly, and then zoom back into that time period as that loads. And you'll see the change that we made to these 2 wells remotely. So let's zoom back in to that time range here. There we go. So you can see the time interval of readings was, I think, on a moderate pace. I think it was, every few hours to every 4 hours, and with the pumping events overlaid on top of that. And then what happened is we increased that interval to every few minutes. And when that happens, you see that the dots get really close together. And it provided us a unique opportunity to track the influence of pumping at one well on the other. So here's that period where the dots get really close together, and those timed readings were really crammed in. So that remote change to sensors was made by administrators at Wellntel from a distance, from Milwaukee, Wisconsin, on these systems in Texas. And if I zoom in even further, let's see if I can do that here. What we'll see is the subtle influence that each pumping event, which you can see by these vertical lines connecting the drawdown and recovery events of the pump at the neighboring well, but you start to see this really interesting pattern of recovery and drawdown in that neighbor's well. So pointing to some really interesting and possibly critical data that'll help inform aquifer characteristics that will then also inform broader decisions about both monitoring and water use in this network. Again, all of this is done really quickly and in real time as these data come into the system, and these visualization tools then enable that work to be done as that data is coming into the cloud. And as opposed to, say, waiting for events like these to be complete, copying and pasting information into spreadsheets, or handling multiple text files or CSVs, and then waiting for charts to be visualized and things like that. In fact, members of both this network science team and technical team, as well as members of Wellntel, can all engage around these charts at the same time. And so that provides a really useful and functional way to analyze this information faster and more effectively than ever before. I'm going to jump over to one other visual that I think can be powerful and important for looking at these data, and that is the compare tool. This tool allows you to select from the wells in a particular network and compare them on the same XY axis chart. In doing this and selecting the appropriate aggregation period, whether we want to look at monthly average or daily maximum or daily minimum, allows us to look at the relationship or the connection between these wells and put some statistics around it. Again, we can look at filtering out specific events, whether we want to compare this with the pumping events that are tracked by the sensors in the field, or just the timed reading intervals themselves, and then add that statistical comparison on top of that, or overlay that on top of that. So what I've done here is add a linear regression model to these data, and then I can actually turn on and view detailed statistics about that regression model, including the basics like the equation for the model itself, the line, and the correlation value and the p-value for that. So with that, I'm going to pause. Actually, one other couple of quick things I'd like to share about this particular network and highlight with reference to it, and that is the opportunity to bring in third-party data. Actually, I'm going to do that by jumping back over to this Wisconsin network and make this bigger. So again, jumping over to Richfield, one of the key components of this conversation is about assembling information. So we've pointed to the the networks themselves and analyzing and assembling data from these monitoring networks, bringing in other data that were collected from these locations, whether it be manual readings or otherwise. But what about other data sources, like federal agencies that are collecting monitoring information all the time, or local agencies, whether they're state or regional, that might have information available in databases or other sources that make it available and accessible for cloud-based platforms like the Wellntel Analytics dashboard. And so what we've done is, as an example of that and as a useful functional tool, is actually connect to the USGS NWIS database, which is a groundwater monitoring database, and allow the user to select a distance or a radius around which they'd like to search that USGS database for monitoring locations. And so I'm going to just pick a radius of 35 miles arbitrarily, and then query the USGS database for data that is nearby. And so on the map, you can see all the different locations. There's obviously some clusters of locations for specific monitoring networks, and then other locations outside and further away from that. And what we can do is then select particular locations that are in this monitoring network and view these data right here on this particular chart, or going back to hydrographs, we can view them there as well. I'm just going to scroll up and highlight that the USGS data are now available as part of the list of selectable sites on hydrographs in addition. And that actually carries through to a number of the other tools that are available in this network. So in addition to the groundwater information or other water or USGS water information, we're also connected with the NOAA NCDC database, the National Climate Data Center. And from there, what we can do is actually query the weather stations that are nearby and view things like precipitation information that might be interesting or valuable for analyzing along with the data from a network. And so what I've done here is search for weather stations in a radius around this monitoring network, and then select to view precipitation from those particular locations. And what we can do then is bring in the water level data and really provides an opportunity for some meaningful analysis of the impact of precipitation that might be happening on groundwater levels there. Okay, with that, I've said quite a bit and probably used up a bunch of our time, so I'm gonna pause there, and I'm gonna hand it back to Nick and Marion to see if there's anything else that I should cover here, or if there's any key points that they'd like to add.
Marion, why don't you go first?
I think you've covered it all, Joe.
Great.
Great. I want to call your attention to one quick thing. This is a part of a series of webinars. Go Beyond the Spreadsheet is the one we've just focused on. It's really an overview of all of AD. I want to call your attention to two other webinars that you might attend. Cloud to Cloud is a discussion about exchanging data between Wellntel and other databases. For example, the possibility of having Wellntel networks inform public-facing websites, or bringing data from existing infrastructure into Wellntel as a data management package. And the second one is make the most of your monitoring budget. Groundwater monitoring is something people have been doing for a long time, but the technologies have been expensive and the methods complex. And this new set of tools, of course, changes that game. And so with Make the Most of Your Monitoring Budget, we can describe how an existing budget might be made more useful or more effective by deploying these technologies, extending the network to the edges, growing the number of sites that can be monitored, et cetera. So at wellntel.com under webinars, you'll find links to both of those discussions, and we'd love to see you at a future event. And with that, I think we're done. Thanks so much, Joe, and and Marion and the rest of the Wellntel team for sitting in, and we'll talk to you all soon.
Thanks very much.
Thank you all.